here that the first thing we talk about when talking about orchestrating agents is what we call routines. And if you have written fairly sophisticated AI applications before, you would have encountered this routine technique of coding LLMs. So basically, this just involves you making multiple calls to the chat completions API in order for you to achieve some desired result where you know exactly what steps need to be followed. And in this blog post, you can see that OpenAI uses the simple customer service routine where you basically just want to search for an item in your database and then offer a refund on that item to a customer. And you see that we have these two functions here which will execute these two steps. So obviously there is no LLM involved in this first example. So if we scroll down here, we'll see that what is happening is, to execute this routine in an actual application, you would have something similar to this. You'll take a user input and obviously append your user messages and then call the completions API using your model of choice. In this case, we're using GPT-4 or Mini. And then once we get a response, we want to make sure that our messages are updated so that we keep track of the conversation. So the code implementation of this is shown here, and then you just have this while loop to simulate how a real world conversation might go. So this simply just waits for a user to input something, and then once we get that user input, we just send our list of messages to the LLM to get a completion. And as you can see, this currently doesn't really involve the routines that we are talking about. And for us to do that, we'll need to implement function calling. And you will see that here, what we are doing is we are defining some helper functions that help us to automatically infer the tool spec that we need to pass into our LLM to tell it about the external functions that it can call. And you will see it here, for example, given this sample function, this function to schema will return a JSON object that looks something like this. So this is the function schema that our LLM will be expecting for it to use the function calling feature. So you can see here, what we're doing is using the existing functions lookup item and execute refund in our routine. We call the function to schema utility function, which will then create the JSON tool spec that we would need to pass in the completion API. And then in the response, we check if there is a function call that we need to execute. And in this case, you can see that the model indeed does return a request for us to execute this lookup item function. And it also gives us the arguments that we need to pass in when we call that function. So basically here in your code, then do something like this. You extract the name and the arguments, and then you get the actual function, and then you call it as we're doing here. So because the LLM can return one or more request for us to execute this function calls, we need to do this in a loop. You see it here. All right. So now putting it all together, you can see that our run for 10 function now is a bit more involved, but it's exactly the same concepts we've been discussing above. First, you specify your tools using the JSON schema, which we discussed before, that we're going to use this utility function to generate those schemas. So we also maintain a tools map in here, so that when the LLM responds with the name of the tool to call, we can just retrieve it from this map. Okay, and then in order for us to check if the conversation must still go on, or if we are done with the active 10, we first check if the LLM returns the content, we print the content, and then we proceed to check if there are any tool calls that the LLM is asking us to execute. And then if not, we break out of the loop, meaning that a single 10 is complete. So a 10 is basically just a one complete cycle that starts when the user sends a message and ends when the chatbot responds. So as you can see, inside a single 10, you can have multiple executions depending on what the LLM is still waiting for from the external tools. You'll see that if the response doesn't have any tool calls, it means that the recent message we got was the final message. Otherwise, we'll run the tools, and to run the tools, you can see here that we're calling this execute tool call, which will take the tool call, the details from the LLM, as well as that tools map where our functions are stored. And then once we run each of the tools, we have to respond back to the LLM with the results of our functions. Then it knows if it needs to make any additional calls, or if it has enough information to send the final response. So that is what is happening here. And then again, we have that simulation of a real world chatbot, which will keep going through these tens multiple times until the user, for example, presses exit. Yes. Yeah. So this is a very important this forms a very important foundation of how this of how you can actually make your large language model smarter by giving it access to external tools. And just to recap, in this case where we're looking at routines, we are looking at cases where we know what steps we want from the LLM. So we literally tell it that call this tool and then call that tool. And then that will then give us our final response. So I hope that is clear. And now I want us to move on to the concept of handoffs. So in some instances, what you want is, instead of having a single agent, you want to have multiple agents which are specialized to a specific task. So basically, if you think about this previous example, you could say this is a single agent because as much as it has two distinct tool calls here, they are still related to the same domain. So in some cases, you want to have to abstract this away as a standalone agent and then extend this to support cases where you want multiple agents with different specialties to collaborate with each other. Okay, so the first thing you want to do, as I said, you want to abstract away the agentic part of the code. So all the boilerplate we wrote previously, you want to just abstract it away. And you can see here that first we define the basic characteristics of an agent, which involves the name, the model to use, as well as the instructions on how this agent should behave. And then secondly, we have this tools parameter here, where we'll again pass in the JSON schema of the tools that we'll make available to this agent. So moving on, we will again have this run full 10, which is very much the same function that we saw previously, where we have our tool schema, which we auto generate using this utility function. And then we keep track of each tool name mapped to the actual function implementation, so that when the agent calls for it using this name, we can retrieve the function and then execute it. All right. Again, we have the completions API, which will either return the message content, which will print to the user, and then check if there are tool calls that the model is asking for. And if there are tool calls, we'll execute all of them and then save the results in our conversation history. And we'll proceed until there are no more tool calls, and the 10 is complete, right? And again, the execute tool call, you see that it takes the details of the tool call that will be written by the LLM. It takes the tool registry or the tool map. Basically, this is just the place where we map name and the actual function to call. And you will see here, we're doing exactly that. We get the name from this detail object, and then we load the argument as a dictionary, and then we go to the registry and say, give me the tool with this name. And then the result of this is a function, meaning that we can then call it by passing in these arguments. So if you've worked with function calling before, you know that these are the arguments that the LLM will come up with depending on the context and depending on what it wants to achieve. All you need to do is to tell it the types or the Python types of your argument, then the LLM will figure out the actual values. So now, because you've abstracted away your agent, you can now start defining different agents which have different specialities. For example, you will see here we have this refund agent followed by this sales agent. All right. And then each of them, you will see they have specific tools. They all have specific tools which relate to their specialty. So the refund agent will have an execute refund function, and then the sales assistant will also have a placeholder function, meaning that it knows how to execute or to place orders. All right. And then we can actually test this out manually to see how we would want this to work in the real world. So if a user says, I want to place an order, we would expect that the sales assistant will be the agent that takes over this request because it is the only one that knows how to place an order. But then if a user says, I want a refund, you would then expect instead the refund agent to handle that request. And notice that here we're doing this manually, But our goal with this handoff orchestration is to have some sort of a way where we can automatically switch between these specialist agents depending on what the user is asking. So instead of us manually saying on this first call we're gonna put the sales assistant, and on the second call we're gonna put the refund, we want to have intermediate step that can automatically pick the agent to answer the user's query. Okay, so how do we achieve that? So it's actually very simple. It still relies on the concept of function calling. So all you need to do is to define a special function called the handoff function, and the only thing that that function needs to do is to return an instance of an agent object. For example, if I define a function like this called transfer to refunds, which then returns an instance of this refund agent, what I'm basically saying is I have received the request, but I don't know how to handle it. So I'm going to return you the instance of the agent that can handle it. And effectively what you're doing then now is doing a handoff automatically. And you can see it concretely down here to see how it actually works. So first, we define this response object here, which we will use to keep track of the conversation history as well as the agent that is currently active in our chat loop. We're using a chat loop because this is an example, but in a real world scenario, you'd probably have a chatbot, but the concept will remain the same. So then what changes does this introduce to our full 10 function? So it's not a lot actually. So the only change is that now you introduce this new variable called current agent. So this agent basically keeps track or points to the agent that we are currently using to answer the question. And the implication of this is that within the same 10, it's possible that the query might be handled by two or one or more agents. Sorry, yeah, one or more agents, right? And let's just go through this one more time. Again, the tool schemas, we've already gone through this, and then the tool registry stored as a dictionary here, and then the chat completions. You'll see that here instead of hard coding the model name, we instead say use the model of the currently active model, right? Because that is the model that will instruct this chat completions API how to behave, depending on that as well as the instruction. I hope that makes sense. So basically what makes this call an agent compared to before is that in here we have specified in that agent object that this is how you need to behave, so your instructions, and then use this model to achieve your goals. Okay, and then again you check if the response has a content, we print it to the user, and if there are tool calls, again we execute the tool calls. Notice though that now we are doing this special check to see if any of these tool calls is one of the special handoff tools. And we check that by saying if the type of the result from the tool call is an agent, this means that the user wants to, or this means that the current agent wants to transfer to another agent that knows best how to handle the current query, right? And you will see here that if that is the case,